Hi everyone, this is Professor Oaks, and in this video we are going to discuss writing fractions as decimals. So here is my first example here. It is write the following fraction as a decimal. Alright, so we have 9 over 16. So we can actually think of this as just 9 divided by 16. So this is actually asking how many times does 16 go into 9? Alright, so I know that it's less than 1 time, so actually I'm going to make this 9.0 and put my decimal point here, and then think about how many times does 16 go into 90? Well, that will be 5 times, because 16 times 5 is actually, well, that is going to be 80. Alright, so then I subtract the 80 and I get 10, and that is a remainder less than the 16. So I know that that was correct, but I want to keep on doing this until I get a remainder of 0. So let's add another 0 here, right, and bring that down. So 16 goes into 100 now. How about 6 times? 16 times 6 we can see is 96. So minus 96, and I see 100 minus 96 is 4. So I still want to get a remainder of 0, so I'm going to bring down another 0. 16 goes into 40, well, 2 times. 16 times 2 is 32, so 2 times. So subtract the 32, so I get 8. Then I add another 0 and bring that down. Well, I already know that 16 goes into 80 5 times, and that's because 16 times 5 is 80, so minus 80, and I get a remainder of 0. So this 9 over 16 as a decimal is 0.5625. Alright, let's try another one here. Write negative 41 over 8 as a decimal. Alright, so I already know this is going to be negative 41 divided by 8, and wherever I get as my answer from doing the long division of 8 goes into 41 will need to be a negative answer. Negative quotient. Alright, so 8 goes into 41 5 times. 5 times 8 is 40, so minus 40 with a remainder of 1, but I know I want to get it down to a remainder of 0, so I'm going to put a decimal point and add a 0, so 8 goes into 10 2 times, well, actually 1 time. 1 time, so 1 times 8 is 8 with a remainder of 2. There we go. So now I know that 8 doesn't go into 2, so I need another 0. So 8 goes into 20 2 times. 2 times 8 is 16. And 20 minus 16 is 4. That's still not a remainder of 0, so I'll bring down another 0. 8 goes into 40 5 times, so negative 41 over 8 as a decimal is negative 5.125. What a time to be alive. Alright, so now let's try another example here. Alright, so let's write the 7 and 12 over 15 as a decimal. Alright, so here is another example of writing a fraction as a decimal. So we know it's going to be 7 and point whatever 12 divided by 15 is. So 12 divided by 15 means how many times does 15 go into 12? Well, 15 doesn't go into 12, so I'll add the decimal here, and 15 goes into then 120 here. Let's say, well, 8 times, so 15 times 8 will be 120. So I know that 8 times 15 is 120, so I subtract that and I get a remainder of 0, and I'm done already. So the answer then is going to be 7.8. All right, 7.8. Now, let's try another one here. Let's write the 2 over 27 as a decimal. So that's 2 over 27 is equal to 2 divided by 27. So that's how many times does 27 goes into 2? Well, it doesn't, so that would be 2.0, but 2.0 and 27 doesn't go into 20 even, so that's 0 times. We need another 0. Well, 27 seems to go into 200. Well, that would be 7 times, so 27 times 7, that will be 189. So 200 minus 189 is 11. Then, how many times, once we bring down the 0, does 27 go into 110? Well, that would be 4 times, so 27 times 4, that would be 108. All right, so 108, and 110 minus 108 is 2. And then we see that we are right back where we started from, because the 27 doesn't go into 2, so we bring down a 0. 27 doesn't go into 20, so we need to bring down another 0. But then 27 went into 200 7 times, and 27 times 7 was 189. So 200 minus 189 is 11. Then we bring down another 0, and 27 goes into 110 4 times. So 27 times 4 was 108. And 110 minus 108 is 2. And you see that the same pattern right here, 200 minus 189, 110 minus 108 will keep on continuing over and over and over again. So this part right here, 074, 074, will keep on repeating. So if you recall, we write a repeating decimal like this, 0.074, and the 0.074 is the part that's repeating, so we write the bar over that. All right, so now let's try to do another exciting example. All right, so here is another example for us to do here. Let me get it ready here. So let's write 88 over 9 as a decimal. So 88 over 9 is the same as 88 divided by 9. So then the 9 goes into 88 how many times? Well, that would be, let's see, how many times would that be? Well, that would be 8 times. All right, so 9 times, oh, sorry. Yes, 9 times. All right, so I think you knew that, right? 9 times 9 is 81, and 88 minus 81 is 7. All right, now we need to put a decimal point and bring down a 0. So now 9 goes into 70. Let's see, that will be 7 times. 9 times 7 is 63. 70 minus 63 is 7. We need to bring down another 0. 9 goes into 70. 7 times. 7 times 9 is 63. 70 minus 63 is 7. I think you see we get the same pattern over and over and over again, and all of these are going to be 7s. So that means that this 88 over 9 is the same as 9.7 repeating. So just the 7 is repeating over and over and over again this time. All right, let's try another example here. Negative 6 and 3 over 11. So we have the answer that we know is negative 6 point something, but 3 divided by 11 means how many times does 11 go into 3? So at 3.0, so 11 goes into 30, then 2 times. 2 times 11 is 22. 30 minus 22 is 8. All right, we'll bring down another 0. So 11 goes into 80. That will be 7 times. 7 times 11 is 77. So that will give us 80 minus 77 is 3. We'll bring down the 0. Then we're back to where we started from. 11 goes into 30 2 times. 2 times 11 is 22. 30 minus 22 is 8. Then we need to bring down another 0. 11 goes into 80. That would be 7 times. 7 times 11 is 77. 80 minus 77 is 3. And then we bring down the 0, and this keeps on going. And the 2727 will keep on repeating forever. So this is negative 6.27 repeating. What a time to be alive. All right. I hope that you really enjoyed that example here. And that, I think, will conclude all of my examples on this topic, because all of these types of problems are just really division problems. So just be careful to watch out for when one or some of the digits start to repeat. All right, I hope that you enjoyed this video. What a time to be alive, and I'll catch you in the next video.